What's good, everyone? Today we're going to be talking about Cramer's rule. Okay, so we're still sticking to the topic of matrices here and systems of equations, specifically n unknowns and n equations. Okay, you might be asking yourself, well, what is Cramer's rule? Okay, we're not talking about John Cramer, that crazy guy that talks about money on what was it, MSNBC, right? This is we're talking about math here. So Cramer's rule is just another way of solving a system of equations. But the nice thing about this is it's kind of an easy way out. And the reason why I say that is it's specifically useful, let's say, if you want to find a specific unknown variable in a system of n unknown equations and n unknowns, right? Now, that's not to say that we can't use this method to find all the unknowns um, of an n by n system of equations, but it's especially useful when you're trying to find one unknown of these, n equations. Okay, that's the main benefit. So you're saying, okay, well, that's cool. Well, what else is a benefit? Well, the great part is you know what inverses are, right? By now you know what inverses are and what it takes to compute an inverse. And let me tell you right now, it's not fun, right? Because even using the Gauss-Jordan elimination, we have to start from the original coefficient matrix, and then we have to flip it with the based on the augmented matrix with the identity matrix. So we start with the coefficient matrix on the left side of the augmented equation, and then it gets transferred to the right side of the augmented matrix with the identity matrix now being on the left side. And that is not fun or easy work, as you could tell and know from practice. It takes some time, and you have to be very careful with the bookkeeping. The nice thing about Cramer's rule is all you have to do is you're dealing with determinants. And we all know how easy it could be to work with determinants, at least at a 2 by 2 or 3 by 3 level, right? So we could determine an individual variable independently. We don't need to find an inverse. It's all dependent on determinants, okay? And like I said, it's applicable to any system of n unknowns and n equations. The only thing we have to make sure we satisfy the criteria, as you well know and remember from a couple of videos ago, is this one condition. It all comes back down to the determinant, right? Just like when we're dealing with a quadratic formula or quadratic equations, there's that discriminant that tells us how many real solutions we have. The determinant is going to tell us if we have zero or any unique solutions, basically, and it's ultimately going to tell us if there's an inverse. And for this purpose of this video, whether we could use Cramer's rule or not. So the only condition is our determinant of the coefficient matrix zero or not? If it's zero, we cannot use this, and you'll see why. Okay, so the general idea of Cramer's rule is we're satisfying this general equation. So bear with me. I'm going to get a little nerdy and geeky here. So let's assume the general situation where we have the system equations of A times X equals to B. Okay, now this is going to be very common once you go on to higher level math, especially in linear algebra, where A is an n by n matrix, which is our coefficient matrix, right? That we're all aware of by this point, okay? X is our n by 1, let's call it our unknown variable, unknown var column vector. Okay, so remember the rules of matrix manipulation here. When you're multiplying matrices, two matrices together, or matrices and vectors, they have to match in terms of let's say they're their n's, right? What I mean by that is, let's talk about this real quick. So A is an n by n matrix. So let's pay attention to this n. So the way the left side of the equation is, A is this n by n matrix. Well, this n has to correspond with another n on the x column vector, right? So let me say that one more time. This end, which is n, right? N columns, rows by columns, has to match the number of rows of this column vector. That's just how matrix manipulation goes. Okay. Now that we got that out of the way, we know what A is, we know what X is, and then we finally have this B vector. So an n by n times an n by 1 is going to give us what? An n by 1 column vector. N by 1 vector of right side equation, right? Apologize for the horrible penmanship. Getting used to it still. Okay, so the B vector is the right side of our equations. So let's say we're dealing with a simple two-dimensional equation, right? So x and y. So for instance, simple case, x plus y equals to 2. Well, that 2 belongs in the B vector. Okay, that's what I mean by the vector of right side of equation. It has all the values that would be on the right side of the equation. Okay, so this is the basis of Cramer's rule. Now that we understand this general equation, so what we're going to do is, the idea is we find the determinant of the coefficient matrix A, right? We store that, we have that on the side. And then what we're going to do is, let's say we're dealing with a 3 by 3 matrix, right? Which means 3 unknowns, 3 equations. So x, y, z. And let's say the question that's posed to you is, I want you to find and tell me what the value of a y is of a certain systems of equation. Well, all you have to do is you say, okay, I'm going to take my column vector B, okay? And since we're dealing with, or we're asked to find the y variable or unknown, we're going to take that whole column B and we're going to replace it inside the coefficient matrix, specifically in the column that corresponds to the y unknown variable. Okay, that might sound confusing, especially since I'm not writing things down, but that's okay, because we're going to jump to the next slide where we're going to get hands-on experience with an example, and maybe even 2 examples. Okay, so bear with me as we move on to this example problem. Okay, so here is an example problem. We're going to deal with 3 systems of equations and 3 unknowns, x, y, and z. So the system that we're given is right here to the left. And to the right of it, we have that general case, right? Remember, A is that n by n of coefficients, and then x is a column vector for our unknown variables, which is going to hold x, y, z in this case. And then B is our column vector, in this case, 3 rows, 1 column, a 3 by 1 as a result. So let's start off by filling in the coefficient matrix of A. A, remember, it's coefficient. So all we're doing is we're taking all those values and we're putting it into a matrix. So 2, I'm going to go top to bottom, left to right. Okay, 2, 1, 1. These are all my x's. Now I'm going to move on to my y's. This is 1, -1, and this is 2. Now I'm going on to my z column for my coefficients of z's, which is 1, -1, and 1. And I'm done. Okay, that is my n by n. Sorry, not n by n anymore. A 3 by 3, our 3 by 3 coefficient matrix. Okay, this isn't really too important, but I'm going to lay it out anyway. So our x column vector is, like I said earlier, x, y, and z. And if you work this out and multiply things back out, a times x, you should get exactly this, okay? It'll work out to come back to this. And then finally, let's write out our b vector, which is our answer column, okay? B is equal to, in this case, I'm looking at the right side of my equation, right side of the equal sign. So that's going to give me 3, 0, 0. Boom. Okay, so far so good, I hope. Now, we are going to check our condition, right? What is our condition for Cramer's rule? Just like when it comes to trying to find the inverse or anything else, when it comes to matrix manipulation, that's right. Let's find the determinant, right? And how do we do that? We want to find the determinant of A. It has to be non-zero for us to continue with this process. So I'm going to write down the determinant of A is, I'm just going to rewrite this, 2, 1, 1, 1, negative 1, 2, 1, negative 1, 1. Now, I'm going to go through this. I'm going to go through this part slow, okay, for this determinant. But the other determinants that we're going to carry on next, I'm going to just blow right through it. So what I'm going to do is, if you remember, do the cross out here, right? I'm focusing on this value, 2, first, and then I'm going to do a 2 by 2 determinant with the uncrossed values. So this is equal to 2. Oh, let me do this. I can't forget to do this, right? Plus, minus, plus. This is to remind me if it's a positive or negative coefficient. So it's positive 2, and I'm going to use my shortcut rule since it's 2 by 2, right? So the rule for 2 by 2 is cross multiply. Now, it's negative 1 times 1 minus 2 times negative 1, okay? So that's negative 1 and 1. That's a negative 1. Negative 1 and 2 is a negative 2, but remember, there's a minus sign in front, so it's minus negative 2, which now becomes a positive 2. All right? So next, oh man, I am going to run out of colors here. I'm just going to use my laser pointer. So you get the idea. You should know how to do this by now. So next I'm going to go down to the second column. And remember, the first row is always crossed out. Okay, don't get it twisted. It's always crossed out. The second column now is being focused. And we realize the second column now is going to start off with a negative. So this is a negative, and the coefficient here is a 1, right? So 1 right here. Okay, negative 1, and using my hack that I remember, it's going to be now 1 times 1, which is a 1, 1 times negative 1, negative 1, and there's a negative sign, so that makes it a positive 1. Okay, and finally, I am going to deal with my last column here. All right, so that is a plus 1 in this case. Okay, and now I'm dealing with this 1 and 2 and 1 and negative 1, right? Okay, so that is a 2 right here, minus 1, which is a plus 1. And time to do some simple maths, okay? Negative 1 and 2, that is going to give me a 1, so this is a 2. 2 times negative 1, that's a negative 2. 2 and 1 is 3 times 1 plus 3, which gives me a discriminant. Sorry, not discriminant. I'm thinking about quadratic equations. A determinant of 3. Does that satisfy our condition? Yes, it does. That means we could carry on with Cramer's rule, okay? So let's try to make this example short. Let's just say that I don't want to solve all unknowns, right? Let's pick a variable. X is overplayed. Let's go with Z. Why not, right? We're in a 3-dimensional space now. This is kind of new territory for us. So let's say I want to solve for our unknown variable Z. Okay, like I said before in the beginning of this video, the nice thing is we don't have to find the inverse. All we have to do is replace the column vector B, the answer column vector B, which is 3, 0, 0, or sorry, B right here, 3, 0, 0, into the column of the coefficient matrix, which is this coefficient matrix, for our unknown. In this case, I said I want to solve for the unknown variable z, and z corresponds with the third column of our coefficient matrix, right? So we're going to take B, 300, replace this column of A, and then we're going to find the discriminant of that, okay? So let's call this phase 2 of Cramer's rule, okay? So this is phase 1, and we're going to do phase 2 right here. Phase 2 is I'm going to replace, and I'm going to call it, instead of A, I'm going to call it AZ, okay? Z to denote that we're dealing or we're replacing the answer column of 300 or the B vector into the Z column of our coefficient matrix. So with that being said, our coefficient matrix now is 2, 1, 1, 1, negative 1, 2. That remains the same. That doesn't change. This is where it changes, okay? So I'm going to change it now by making it blue. I'm going to say, now it's 3, 0, 0, okay? So remember that 3, 0, 0, this thing right here, comes right from here, from B. Okay, great. So what do we do next? Well, we take another determinant, but this time we're taking the determinant of AZ, okay? Determinant of AZ. And now I'm going to fast forward, okay? So let's see, that's a 2. And that means, well, the nice thing is zeros, right? So negative 1 and 0, that's 0. Minus 0. Boom. Great. Okay, negative 1. Okay? So now, oh, beautiful. So 1 times 0, that's another 0. 1 times 0, another 0. Or as DJ Calloway would put it, another 1, right? Okay, plus 3. All right. All right, now unfortunately we got to do some math. So 1 times 2, that's 2. 1 times negative 1 is a negative 1. Multiply it with a negative, right? So that's a positive 1. Okay, now we just add it all together. So this first thing right here, this is 0, and this is 0. Whew. Okay, that saves me some time. So now it's 1 plus 2, 3, 3 and 3, that's a 9. Okay, so now we have 2 determinants, okay? So the final step, phase 3 now, is this, okay? And this is why it's very important for the determinant of the original coefficient matrix to be non-zero, okay? So to find that unknown variable z, we are going to have to take the determinant of az, which we got from phase 2, divided by determinant of the original coefficient matrix, okay, which is from phase 1. Now, do you see why it's very important to not have the determinant of the coefficient matrix to be 0? It's because whenever we divide by 0, funky things happen, right? We don't like to divide by 0 because we get crazy things like, let's say, vertical asymptotes or asymptotes in general, right? So that's why we have to make sure that the determinant is not 0. In this case, we're good to go. So all we have to do is just plug in the numbers. The determinant of a sub z, as we found out, is 9. And the determinant of a is 3. So that tells us what? 3. So that tells us, okay, well, we just found the answer. We know what the unknown variable of z is. It's 3. And that's it. That's all there is to it. Now, if you want to find the other 2 unknowns, or you're told to find the other 2 unknowns, that's easy. All you have to do is rinse and repeat from step 2, right? Or phase 2. And instead of AZ, let's say you want to find X, right? So you want to find X, now it's going to be called A sub X, but instead of substituting the 300 into the third column, you're going to substitute that B vector into this first column, which is where the 2, 1, 1 is, because you're solving for X. Same thing if you're trying to solve for the variable Y. You would want to substitute it into this middle column. And that's all there is to it. See how nice and easy that is compared to the Gauss-Jordan elimination, where you actually have to find the inverse matrix and do all this bookkeeping to find the inverse, and then you're not done there yet, because once you find the inverse matrix, you have to now multiply it with your B matrix to ultimately get your X vector, right? Which is finally your ultimate solution. That is a lot of work, guys, and that's something I know for sure I don't have the time for. Okay, but yeah, that's it. That's all there is to Cramer's rule. So I'm gonna try to make another video, an example video, going through all the steps again and potentially solving all the rest of the unknown variables too. But in terms of material, content, and what there is about Cramer's rule, that's it. Simple as that. All right. Hope to catch you guys in the next one. Peace.